Okay, so our first one is number 7, and on number 7, we want to know the relationship between angle 2 and angle 6. So we go over here, we see angle 2 and angle 6. What relationship do we have?
Corresponding.
We have corresponding. So I'm just going to write core angles. Core angles. Our next one is going to be 8 and 1. 8 and 1 have what type of relationship? Yep, we have alt exterior angles. Okay, next is 3 and 6. 3 and 6 are alt interior angles. And last but not least, we have 4 and 6. 4 and 6 are same side interior. You could also call those consecutive interior angles. That's also one that they've talked about. So now we're finding the measure of angle 1. So what is the relationship between these two angles? There isn't one, right? So we have to use a little bit of other information. I could either use the fact that 1 is vertical with this angle, and these two angles are same side, and know that fact. Or I can use corresponding angles and know that these two are linear pairs. Which one would you rather use? No preference? Okay, so let's use the first one's vertical, which means that this is also the same measure of angle 1. We now know that these two angles are the same side interior, which means they have to add up to what? 180. So we have 180. We're going to subtract 37. When we subtract 37, we get the measure of angle 1 equals 143. Thank you, sir. Now we're done with that one. The next one, we see again, what's the relationship here? Not vertical. Same side interior. So same side interior, we know same side interior add up to 180. When we subtract, I get 71 degrees. Here we see that these are corresponding angles. Corresponding angles are congruent, which means that x has to be 57 degrees. Okay, now we have a relationship between x and y. What's the relationship between x and y? They are linear pairs? No, that's what I do with linear pairs. So y equals 180 minus 57, which equals, what is it?
123.
123. Did we just do this one?
Nope.
Okay. Our next one over here, we have another relationship. But we see here, what is this? These are linear pairs. So 180 minus 50, which gives us 130 degrees. And so we see that this is 130. These two angles, x and 5y, what type of relationship do we have here? We call these relationship.
Oh, those?
Yep, they're corresponding. Okay. So 130 equals 5 at y. Divide by 5. Divide by 5. Y equals 26. Okay. Our next one wants us to explain how we know that these are parallel. How do we know that M is parallel to N? So here we see that the corresponding angles are congruent, and therefore by corresponding angle converse, so core angle converse, they are congruent because corresponding angles are congruent. Our next one here, we have to create a little statement. We see that M is parallel to P and P is parallel to N. So we can say that M is parallel to N by the transitive property. And our last one here, what's the relationship between these two angles? Same side interior. So for them to be parallel, they have to add up to what value? So let's add them up, see if they equal 180. They do. So by same side interior, converse, they are parallel. Okay, do we have any questions?
Can you wait a second for you change?
Yes, I can. Here, I'm going to clear this slide. Our next group of problems are here. We want to describe these translations. We're going to describe the translation. So our first one says describe it in words. So you pick a point and make sure you move it to the one that has a prime of the same letter. So if I did A to A prime, I'm going to draw my line to show me how I connected it. I went right how many? So 4. And then I went down. Okay, so when I write this in words, I went right 4, down 3. And then to write it in symbols, we're at X, Y, arrow, X plus 4, Y minus 3. The next one, we're going to do the same thing. You pick your point, go to its image, the one with the prime. We see that C goes to C prime this way. So it is right 1, up, how many? 2. We write it again, X, Y, little arrow, X plus 1, Y plus 2.
Wait a hot second.
Yes.
No, I just need to
Okay. Next one is we are classifying. Coda, do you need a second? So we're classifying by angles. This triangle here, is it obtuse, acute, or right?
Right.
It is right. Yes.
I have a question.
No, I was turning to me.
Oh.
Or do you want us to wait?
We have here, is this obtuse, acute, or right? Obtuse. Because it's greater than 90 degrees. I went too far. There we go. The next one. We're classifying it by sides. You see the little tick marks. What type of triangle is this? Next one's what? Scalene, because they do not have the same. Yes.
Can I write?
Number 2, can I see what it looks like? We're classifying it by angles. So the only thing we can officially say is that, but yes, they have the same angle measure, so you know it's isosceles as well, but you only needed the one for the
Can I write on
angles.
that, Miss Jenkins?
Not right now. Okay, so our next one, we want to find the missing angle measure. So the sum of the interior of a triangle adds up to 180. So I take 180 and subtract what?
102.
Minus 102. And how he got that was 40 plus 62, so that's supposed to be 102. I'll erase it so it looks a little cleaner. So that gives me 78. Our next one is an exterior angle. Remember, the exterior angle equals the sum of the two non-adjacent interior angles. Subtract 60. Subtract 60. So we have the measure of angle 1 equals 60 degrees. And our last one is finding that measure of angle 1 again. So the measure of angle 1 equals 45 plus 60. Add those together. The measure of angle 1 equals 105.
Is it? This? Alright, never mind.
Ask the question if you have it.
Nah. I thought that was a 68.
Oh, I'm sorry. It's a 60.
It's all good.
Okay, question.
Yes, ma'am.
So,
That we have two angles that are congruent. The sides opposite of congruent angles are congruent. Yep. So we have 7 equals x plus 5. Subtract 5. X equals. Okay, our next one, we see we have all of these little tick marks, which tell me what?
Equilateral.
They're all congruent. It's an equilateral triangle.
Actually, it's equiangular.
And so equilateral triangles are equiangular. So what are the measures of an equiangular triangle? How much is each angle?
60, 60, 60.
It's 60, yep. So we have 60 equals 3x. Divide by 3. X equals 20. So you get that by 180 divided by 3. So you have 3 said the exact same. So 180 divided by 3 gives you 60 degrees.
somebody let me know when it's like, I'm gonna set a timer on my phone. Can I set an alarm on my phone?
No, I'll remind you.
Oh, okay.
Okay. Any questions up to this point? We have okay, so Ethan's already solved it. We have an equiangular triangle, which means it's equilateral. which means our sides are the same. So I have 21 equals 4x plus 1. I have to solve. I subtract 1, subtract 1. I have 20 equals 4x. Ethan, what's my answer?
Got him.
Okay, over here we see that when we have congruent sides, the angles opposite of congruent sides are congruent. So that means that these have to be congruent. So x equals 75 degrees.
That was easy.
Not so bad. Do you need another second? Okay.
Nah, we do.
What is our Pythagorean theorem?
A squared plus B squared.
Okay, what is our c squared? It's the side opposite of our right angle. So hypotenuse, that's 26 squared equals a squared plus 10 squared. We have a squared plus 100 equals, what is 26 squared? 676. We're going to subtract 100. We have a squared equals 576. Square root both sides. A equals 24.
Say the 14.
It is a 7. It's the 13th. So our next one, we have c squared equals 40 squared plus 9 squared. We have c squared equals 1600 plus 81. We have c squared equals 1681. Square root both sides. C equals, what is the square root of 1681? 41. Thank you.
Why are you doing it backwards?
It doesn't matter either direction you can do it. You can write it either direction. A squared plus b squared equals c squared. C squared equals a squared plus b squared. I'll do it the other way. 8 squared plus b squared equals 10 squared. 64 plus b squared equals 100.
That's 40. Is that 41 or is that 46?
64. Say it again.
Is that 41 or 46?
It's 41.
Alright, next one.
B squared equals 36. Square root both sides. B equals.
Can you slow down?
Yeah, pause. So now that we have the formula, let's go through and solve it. So we have A, B. Remember, x is first, y is second. X is first, y is second. Equals the square root of x2 is 3 minus 6 squared plus 1 minus 5 squared. We combine like terms. I will give you a second. Okay, so here we see that we have negative 3 squared, which is 9. Negative 4 squared is, which equals the square root of 25. Square root of 25 is 5. Over here, we're doing the same thing. We have AB, which equals the square root of, remember it's xy, xy. So x2 minus x1 plus y2 minus y1 squared. Here we end up with the square root of 8 squared plus 15 squared. 8 squared is 64 plus 15 squared, which is? I think it's 225. Double check my math.
I don't know.
15 squared. Anybody want to double check? I wrote it up, but I wanted to make sure it was correct. I just did it off the top of my head.
Which part?
15 squared. What's 15 squared?
225.
It is? For a fact? Okay. Just want to make sure before we go too far. Okay, 64 plus 225. Square root of 289? What is it? 17. Thank you, sir. 17 is our answer. Our next three we're going to do. This is where we tell the triangle is acute, obtuse, or right. So here, remember you pick your biggest side. Our first one, we don't have a biggest side. They're all 3. So we end up with 3 squared, box, 3 squared plus 3 squared. 3 squared is 9, box, 9 plus 9. We end up with 9, box, 18. Is 9 greater than, less than, or equal to 18? Okay, and so we say that is what? Acute. Okay, over here, we have 25 squared box 15 squared plus 20 squared. 25 squared is
625.
625 box 225 plus 400. 6. So 625 is what to 625? Equal to. If it's equal, it means it has to be right. And last but not least, we have 17 squared box 9 squared plus 12 squared. I'll fix my 9 in 1 second. Thank you, ma'am. So we now have 9 squared. 17 squared is 289. 289 box 81 plus 144. 289 box 225. 289 is greater than that. So is it acute, obtuse, or right? Okay, I'm going to clear the slide. Are you ready? Okay, our last 3 on this first part. I guess we have more than 3. Let's get through them. So when you're doing this, we have medians and centroids. Remember, the centroid is where all your medians meet. We know that the value of RV, the distance, is 42. We have a 2x and we have an x. Is 2x going to be RV or RU or UV? So RU is going to be the 2x. So we know the total length is RV, which equals RU plus UV. We know here we have 42, which is now equal to 2x plus x. We have 42, which is equal to 3x, divided by 3, divided by 3. X equals what?
14.
Okay, so then that's not what we're looking for. We're looking for RU. RU equals 2x, which is 2 times 14, which is 28.
What is 21? 14. What is that?
14 times 2 is parentheses.
Oh, okay.
100 multiple choice questions worth 200 points. 100 multiple choice questions worth 200 points. Okay, our last one, for the one that I'm on at least, I keep saying the last one, but it's not the last. We're going with the longest side and smallest side, or no, smallest angle, largest angle. Smallest angle is going to be across from the smallest side. My smallest side is 23. The angle directly across from it is angle A. My longest side is 34. The side opposite is B. Over here, we want to name the shortest and longest side. My shortest side is going to be across from my shortest angle. My shortest angle is 31. So my shortest side has to be BF. And then we have longest side, which is going to be across from my biggest angle, which is DE. That's right, class. Okay, our next group is talking about being congruent and given that congruent statement. So we know that triangle ABC is congruent to triangle XYZ, and we need to determine the congruence of each part. So if we are given angle B is congruent to angle Y. Thank you, ma'am. Because they're in the same spot. We also know that AC is congruent to XZ. Yep.
Can you scroll up?
I can. You ready?
Are you ready?
Okay, guys, let's stay focused. Okay. So we now have Z, which is congruent to C. And we have YX, which is congruent to, we're going to say BA because we wrote the Y first. So BA. Yeah, let's do those again. So B was congruent to angle Y because they're in the same position. It's not an eraser. angle y. And then AC was congruent to XZ. So the next one tells you which postulate they want you to use. They want you to use side, angle, side. Right now we have a side and we have an angle. What else do we need to be congruent? We need the other side. So which side do we have to show? So we have a side. We have an angle. So what side are we missing?
Another side.
BC is congruent to CE. And then over here we have angle, side, angle, but we have two angles. So which side do we have to show in the middle? So we have angle, 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 angle. Congruent sides are? Thank you, sir. Okay, and our last ones on this page. Is there enough information? So the first one, is there enough information? Which postulate would we use? We have two congruent sides that are drawn on there. Which one? Do we have enough information to prove it by side, 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 angle, 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 side? Hypotenuse. We can use side, 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 and how'd you know that? You know, because EG is congruent to EG by reflexive property. Number 2, we have angle, angle, angle. Is that one of your theorems or postulates? Do we have an AAA? Nope. And last but not least, we have a right triangle with two congruent sides. What could we use? We can use hypotenuse leg. You have a congruent hypotenuse and a congruent leg with a right triangle. Okay, last 3. You ready? Yes, there's 5. Okay, so our next 2, our first one, is it reflected over the X, the Y, or neither? So is it reflected like this or like this? It's reflected over the X. Is this one reflected over the X or the Y, or neither? So it looks like it could be Y, but you see it's shifted, so we're going to say neither. And then our last 2 or 3 are symmetry. How many lines of symmetry do these have? You have 2 here. Do we have a line of symmetry with this one? No. And how about here? 1.